Good morning students, this is Laiko Khalsa College of Engineering Jalandhar, and today we again discuss the integration of some standard trigonometric function. As we discussed in the previous lecture, rule to find the integration from 0 to pi by 2 sine raised to power nx dx or 0 to pi by 2 cos raised to power nx dx, where n is a positive or a negative integer. We discuss this integration. In this we divide the n into two parts when n is a even positive integer and when n is a odd positive integer. So we once again quickly remember the formula. Integration from 0 to pi by 2 sine raised to power nx dx equals to n minus 1, n minus 3, n minus 5 plus up to so on factor, a positive factor over n minus 2, n minus 4 up to so on positive factor. Same is formula for the cos, and in case when n is a even integer we multiply with the pi by 2, otherwise no pi by 2 is multiplied. So this is the formula to solve the integration 0 to pi by 2 sine nx or cos raised to power nx dx. Similarly, we discuss one more formula to evaluate the integration from 0 to pi by 2 sine raised to power mx cos raised to power nx dx, where m and n are positive integers. So again the formula to solve this is divided into two parts. When first is when m and n both are odd or either one of them are odd, then integration from 0 to pi by 2 sine raised to power mx cos raised to power nx dx equals to m minus 1, m minus 3 up to so on. Up to so on means up to so on positive factor, n minus 1, n minus 3 up to so on, up to so on means again for up to a positive factor, over m plus n minus 2, m plus n minus 4 up to so on. And same when m and n both are even integers, then we multiply with the pi by 2. So we discussed the two or three examples to solve this integration. Now we discuss more example to solve the integration based upon these two formulas. Let us suppose we want to solve or we want to evaluate the integration from 0 to 2 x raised to power 4 over under root 4 minus x square dx. So to solve this integration, firstly we can let us suppose the integration I equals to 0 to 2 x raised to power 4 minus x square dx. Now to solve this integration or to simplify this integration, we substitute x equals to 2 cos theta. So if our x is cos 2 sine theta, we put x equals to 2 sine theta, then our dx means derivative, dx equals to 2. We know that derivative of sine theta is cos theta into d theta, because we find the derivative here with respect to theta. So corresponding to this substitution, now we change the limits, and we know that when x is 0, here if we put x is 0, then theta equals to sine inverse 0, and we know that sine inverse 0 is 0, so our theta is 0. When we substitute x equals to 2, we check that if here we can write 2 equals to 2 sine theta, then 2 over 2, that means this is equals to 1 equals to sine theta, and we know that 1 equals to sine theta implies that theta equals to sine inverse 1. So we know that sine inverse 1 means theta is pi by 2, because sine pi by 2 is equals to 1. So from that we find the value of theta is pi by 2. Now corresponding to this substitution, we change this whole integration. Then I integration is lower limit is 0, corresponding to 0, theta is 0. So here we can write 0. Upper limit is 2, so theta is pi by 2. We can write pi by 2. Instead of x, we can put x equals to 2 sine theta. So 2 sine theta raised to power 4 means sine raised to power 4 theta, and 2 raised to power 4 is 16. And value of dx is 2 cos theta d theta. We substitute this value also. Denominator term is 4 minus x square. If we find x square, this is equals to 2 square equals to 4 and sine square theta. So corresponding to this substitution, our integration is converted to 0 to pi by 2, 16 into 2, 32, sine raised to power 4 cos theta. From this whole term, if we take 4 is a common, then from under root 4 is written as a 2. And here the remaining term is 1 minus sine square theta. And we know that 1 minus sine square theta is equals to cos square theta. So under the root, cos square theta is equals to cos theta. So this term equals to cos theta. Now 32 over 2. 32 over 2 is 16. So here we can write 16. Then cos and cos are cancel out. Cos and cos are cancel out. We have the term only sine raised to power 4 theta d theta, and limit is from 0 to pi by 2. Then this 16 as it is. Now if we compare this integration with integration 0 to pi by 2 sine raised to power n theta d theta. So the value of n is 4. Value of n is 4. 4 is even number, so we multiplied with the pi by 2. Pi by 2, here we can write n minus 1. 4 minus 1 is 3. N minus 3, 4 minus 3 is 1. N is 4 and 4 minus 2 is 2. So if we simplify, 2 to the 4, 4 for the 16, 16 and 16 cancel out. 3 into 1, 3 pi. So that is our answer for the integration. So now we discuss one more example. Evaluate the integration from 0 to infinity dx over 1 plus x square raised to power 4. Firstly, we suppose that the given integration as I. Let the integration I equals to integration from 0 to infinity dx over 1 plus x square raised to power 5. So again, to simplify that integration, we substitute the value of x equals to tan theta. So if we find the derivative, we know that derivative of x is dx. Our dx is secant square theta d theta. Now corresponding to this substitution, we change the upper limit and the lower limit. So when x is 0, if we here put x is 0, then our theta equals to tan inverse 0. And we know that tan inverse 0 is 0. So our theta is 0. If we put x equals to infinity, infinity equals to tan theta, which implies theta equals to tan inverse infinity. And we know that the value of tan is infinity at an angle pi by 2. So our theta is pi by 2. So our integration is 0 to pi by 2 value of dx. We substitute the value of dx is secant square theta d theta. 1 plus tan square theta raised to power 5. And we know that 1 plus tan square theta equals to secant square theta. So this value equals to secant raised to power secant square theta raised to power 5. Then 2 into 5 raised to power 10. So, if we simplify that, this is equals to 0 to pi by 2, 1 over secant raised to power 8 theta d theta. And we know that 1 over secant theta equals to cos square theta. So, this is equals to 1 over secant theta is cos theta. So, this is equals to cos raised to power 8 theta d theta. Again here the value of n is even. If we check, the value of n is 8 and n is even. So, we multiply with the pi by 2. So, our integration is n minus 1, 8 minus 1, 7, 5, 3, 1, 8, 6, 4, 2. So, if we simplify that, this is equals to 35 pi over 256. That is the answer for our integration. So, these are the some application or some standard forms of definite integral. So, now we discuss our next topic. Application of integration. So, in this topic we discuss the integration or particularly definite integral to find the area under the curve or volume by revolution. So, firstly we discuss the area under the curve by integration. So, first we discuss the formula to find the area under the curve. The area under the curve between the 2 points can be found doing a definite integral between 2 points. So, if we want to find the area under the curve between the 2 points, then this can be done with the help of definite integral. To find the area under the curve, let us suppose our curve is y equals to fx. Curve is represented by y equals to fx between the points x equals to a and x equals to b. So, the area is given by solving the integration from a to b y dx. So, this is our first formula to find the area under the curve, and our curve is y equals to fx and x varies from a to b. So, if our curve is x equals to gy and our y varies from c to d, then the area is given by integration from c to d x dy. So, this is our formula. If the curve is given in terms of y and limits for y are given, this is the formula. First formula is if the curve is given in terms of x and limit for x are given. So, with the help of the definite integral, we find the area under some particular curve by using these two formulas. So we discuss the one example based upon this concept. Find the area between the curve y equals to 2 plus x and x axis. We want to find the area between the curve y equals to 2x and x axis. As we write here, the area is given by integration from a to b y dx. So, this is the formula to find the area. Here, the value of y is 2 plus x and the limits are obtained by using the concept of x-axis. And we know that at x-axis value of y is 0. So, if we write the value of y is 0, then our value of x 0 equals to 2 plus x, x equals to minus 2. So, to find the limits for integration, we use this concept. Okay, we want to find the area between the curve y equals to 2 plus x and x-axis. So, if x-axis means value of y is 0, so we find the value of x is minus 2. So, our area is, because area we want to find between the x-axis, 0 to minus 2, y 2 plus x dx. Now we solve this integration, and after solving this integration we put the limits. So if we solve the integration of 2 is 2x, integration of x is x square over 2. After solving this integration we put the upper limit. 2 into minus 2 is minus 4, minus 2 square over 2 is 2, lower limit is 0. So answer is minus 2. So our area is 2 square units, but area is always a positive. So here we use the positive sign, or we neglect the negative sign. So to find the area we use these two formulas. So if you have any doubt in this topic, kindly contact with me. Thank you.